Usha ma'am?
Yes, sir.
So like it's 4:48. So can we start the things?
Yeah. One second, let me see whether my presenter is available.
Yeah,
Yeah.
please ma'am.
So the next
I'm there.
presentation, yeah. So the next presentation will be done by Ms. Smita Wangikar. She is one of our project managers, and she is taking care of the R initiatives which we are doing under FOSSI. And the professor involved with the R initiative is Professor Radhendushka Srivastava from the Mathematics Department of IIT Bombay. So Smita, you can start.
Okay, I'll just share my screen.
Sir Amit sir, can you please make her the presenter?
Yes, ma'am.
Thank you, Amit sir.
Yes, ma'am. Now I have already.
Okay. Yeah. So is my screen visible?
Yes, Smita, it is visible.
Okay, thank you. Good afternoon, everybody. This is Smita Wangikar. Today I'm going to talk about R programming language. R programming language is basically used for statistical computing. Basically, it goes hand in hand with Python and R. Basically, it is very good for data science analysis. So R is used for statistical computing. So these are the few applications available, applications of R. It is used for basically data visualization, predictive modeling, machine learning, forecast analysis, and as well as data manipulation and statistical analysis. There are few more applications here. Actually, today I'm going to talk about more about applications because programming you can learn using our spoken tutorial. So here I'm going to show you where you can use R so that if you find it useful, you will start using R. So these are few applications. So R is used for data management as well as statistical summary and graphical representation of data. So basically currently there are more than 16,000 packages available in R. Packages means basically there are set of codes written and there are few functions included. So your actually line of code will decrease. So there are readily packages available so that you can use it for your calculation. So here are few packages I will explain you. Stats is a basic statistical computation package available with basic of R. So once you install R, you will get stats package as an inbuilt package. Similarly, actually ggplot2 in basic R package, you will find plot function. But if you want to use advanced feature of graphs or plotting, you need to use ggplot2 package. It has very good actually features and options available using which you can plot 2D graphs. For 3D graphs, here you can use RGL package, which is very useful. Similarly, for classification and clustering, respectively, E1071 and cluster package you can use. So these are a few, actually there are few more packages available for classification as well as clustering, but here I am showing you just as an example. T-series forecast and RU-GACH packages are available for linear and non-linear time series analysis. So here I'm going to show you one example. Basically, nowadays people are talking about artificial intelligence, machine learning so much. And that for that they use a proprietary software like MATLAB, SAS, SPSS. But I want to guarantee you that R is also equally capable of handling AI and ML very well. Here, actually, we have shown you one example using artificial neural network to predict species. Here we have used Irish dataset, which will predict species on the basis of sepal length, petal width, sepal, sepal length, sepal width, petal length, petal width. Here you can see there are 3 hidden layers, which will actually lead you to the prediction. If you use artificial neural network, which is also known as ANN, if you use it for prediction, your prediction accuracy goes really high. Okay. So next is here actually there are many softwares available for simulation. Simulation can be also done using R. Here I'm showing you one example in Schelling's model of segregation, where we have actually done it using animation. For this purpose, we have used package called animation and magic. So R can handle simulation as well as animation very well. So you can use R for this purpose. There are so many actual web applications available in the market, but R independently can handle web application as well. R Shiny app is available for that purpose. This example I'm illustrating here is this R Shiny app is developed by our summer fellows from 2019, who has developed this R Shiny app. They have done actually basically data analysis of rainfall data for Indian weather for 111 years. So what they have done is they have actually plotted it here. If you see different different shades of blue color represents the amount of data they receive. So darker the shade is, the more the rainfall. And so here in the sidebar, you can see they have given option. You can actually check rainfall month-wise and so on and so forth. So now I'm going to talk about the activities available in R. Once you know how to do programming in R, I would like you to contribute to our activities. So these are the activities available with us. So I'm going to talk about it in next few slides. I'm going to talk about it in detail. So textbook companion project. Similarly, like I think Professor Kannan has explained it in detail yesterday about textbook companion project. Like Scilab, we also have textbook companion project wherein actually students, faculty members, or researchers can contribute. So currently there are 34 books available for the reference. These books are actually from different streams like engineering, management, economics, psychology, business statistics, of course, mathematics. So like Scilab, we also have developed search engine in R. So if you want to particularly search about some particular function, if you type in, there are examples available which are actually used in the textbook companion project. So you can actually take help from that. So similarly, we have a cloud version for TBC, wherein you can actually check the example, then make some changes if you want, see how it works. So similarly, like Scilab, as I think sir has explained it very well yesterday, so I'm not going to explain it in detail here. Once you have a successfully, once you complete the submission of codes, and we will evaluate your code, and once the one book, actually you write a code for one book and it gets approved, then we issue e-certificate. And we have a separate link for on our website for individual work. That means for each book, we have a separate link available. So lab migration project. Lab migration project is mainly for faculty members like you actually. So if you want to migrate your lab from proprietary software to FOSS-free, like proprietary, I mean SPSS, SAS, if you're using in your college for the purpose of conducting labs, we help you to migrate these labs to R, because whatever you can do in SPSS and SAS for the college purpose, definitely, all that can be done in R. So currently there are 5 labs available. And for this purpose, actually, we issue certificate to faculty member who propose the lab, and same thing for even head of the department and principal who actually approve the lab migration. So one can download lab solutions and use it. In fact, if you want to set up a lab, we help you in setting up a lab. We also write a code for you. If you are well versed with the actually coding, then you can also you have to basically propose a lab, and then you will only give a solution for the lab migration. So, but it will be freely available to others on our website so that they can also take help from that. Next is case study project. Case study project is newly, actually we have introduced it recently. Case study project we have thought of keeping in researchers in mind. Like first for TBC is for students, second is for faculty, third is for researchers. Here you can see that these are basically we wanted to cover up all the features available in R. Once you do one case study, you will use many features in R. So this is mainly useful for researcher or students who wants to do some research, taking up some particular one topic. And so for that, we actually ask student or researchers to submit abstract with the data set, and we will review it. And then we actually, once they get approval from us, they can go ahead and complete the case study. In that abstract, they will actually basically let us know what all analysis they are planning to do it. And accordingly, we will see whether it is feasible or not. So recently, with the help of our in fact, 3 summer interns 2020, we have done a sample case study. So these are the topics we have covered actually for this case study. So it was very relevant as it was related to COVID. It is actually study of effect of COVID on Sensex data. And so this case study was done actually under the guidance of Professor Radhenushka Srivastava, who is also co-PI for R. For this purpose, we issue e-certificate. Once you complete and your case study gets approved and published on our website, of course, you will get e-certificate. So as I said, we have spoken tutorials available on basics of R. If you don't know programming, there are 22 tutorials available right from installation of R Studio. R Studio, by the way, is actually very good GUI for the R package. So there are many features available and it is very easy to use it. So don't get afraid if you're new to programming. Okay. So here actually we have created 22 tutorials on different topics. In fact, using ggplot, plots, pipe operator, and then tidyverse, actually how to use tidyverse package and those things. So actually using these tutorials, we have conducted 2 massive workshops last year, wherein more than 3,600 actually participants attended this workshop. So actually next our plan is we are planning to introduce new a series which is based on classification and clustering. So if you are interested on different topic than classification and clustering, you are welcome to actually join or contribute. So using these tutorials, as they are freely available, you can conduct your own workshop using spoken tutorial. With this, actually, I come to the conclusion of my presentation. This is my team. So you know Professor Rajanushka Srivastava, he is from Department of Mathematics. Myself, Smita Wangikar, and Project Assistant Digvijay, who is also available right now with us for the question and answer session. Okay, so actually you can contact us on contact-r for any further queries related to our activities, or if you have any query related to our programming language, we are there to help you out. Okay. So if you have any questions or anything, please let us write to us. We are available. Okay. So thank you so much for paying attention, and I hope you will find all our presentations useful. Please contact us. And here is actually this QR code, same for, there are only one or two questions related to R. You can actually scan this QR code and answer the questions. I think there are only two questions. Maybe I can wait for your response, or meanwhile I can take a question and answers if you have any. Hello?
Yes, yes, ma'am.
Yeah, so we will wait for them to take this quiz, or meanwhile I can take some questions if you have.
Okay. I think one question from Gopal Krishna as that what type of support you extend for a lab setup?
Yeah, we actually basically only thing we can check their syllabus. If they don't have lab already in R or any proprietary software, we will help us setting up or creating a lab for their coursework. Basically, we will see their syllabus, and depending on that, we can suggest few experiments, and we can actually number of experiments we can actually suggest them. If they are willing to write a code for that experiments, they can do that, or we can also help them in writing the code and all this, give all the solutions.
Okay, thank you, ma'am. And another question from Prakash Singh that is it possible to contribute in management stream course?
In management, sorry, I didn't get it.
Management stream course regarding the management.
Yeah. If it is related to, I think, statistics or some mathematical thing, definitely we can actually. So there are books in TBC. If you see, there are books available in managements as well, but it is related to statistics or that kind of thing.
Okay. I think, ma'am, that's all. I think.
Okay.
Thank you, ma'am.
So should I stop sharing my screen?
Yes, ma'am. I think I can make. I think Slave is the next presenter. Should I make?
Yeah.
Yeah, I'm here. Can you make me the presenter?
Yes.
So Ashley is working in our open form team, CFD team, which actually deals with the software open form. So the professor who is involved with this initiative is Professor Janani Sri Muralidharan of Mechanical Engineering Department, IIT Bombay. And Ashley actually works with the CFD team, and the manager in the team is Ms. Shweta Sridhar. She is also available as a panelist. So over to Ashley.
Thank you, Shannon. So am I audible and my screen is visible, right?
Yes, but there is a, on the screen there is some, is it me only seeing that, or okay, now it's better. Yeah, now it's visible. Yeah.
All right. So hi, good evening, everyone. I'm Ashley, and today I'll be talking about computational fluid dynamics, or CFD, OpenFOAM as a CFD tool and how it stands out compared to other CFD software as a free and open source software. with readily available source code for all kinds of modifications. I'll also be talking about what we here at FOSSI do to promote OpenFOAM. So this is our team. We are headed by Professor Janishri Muralidharan of the Mechanical Engineering Department of IIT Bombay. The project is managed by Ms. Shweta, and my colleague Divyesh and I, we form the research team of this project. Now, all these beautiful animations that you see, it's possible only because of CFD. And as you all know that students have to actually resort to commercial CFD software for such solution. And for most day-to-day engineering application, that would be enough. But as a research tool, these commercial software perform very poorly. We actually need a software that can give us control at each stage of a CFD analysis. And this is exactly what OpenFOAM does. Talking about stages, the first step to solving any problem numerically would be to discretize the domain. This would come under the meshing in OpenFOAM. The second step would be discretizing these equations, and that's where our discretization schemes come in. And the third one would be solving these discretized equations using a suitable solver. And lastly, we need to view and analyze these results. About OpenFOAM, OpenFOAM is an open source CFD toolbox, but this is not a very rigid code. I would call it an open source C++ library of classes for writing CFD codes. However, for students who want to just use this as a black box tool, OpenFOAM comes with pre-written solvers as well. This means OpenFOAM can work just like any other commercial software if that's all what is required of it. Talking of pre-written solvers, these are the standard solvers that we have, and almost all the CFD applications that come in, they come under one of these categories. But it's just not that we have domains related to CFD in the OpenFOAM. We also have solvers in other domains as well. OpenFOAM even has solver that solve problems in the field of finance. So one of the OpenFOAM solvers called Financial Foam solves the Black-Scholes equation for pricing commodities if anyone is into the financial domain. And this shows how diverse OpenFOAM solvers are. We have more than 10 solvers, as you can see, just for the incompressible flows. And all these solvers are named very intuitively as well. So the ICOFOAM, the first solver that you see, it solves incompressible laminar flows. And the third solver that you see on your screen, which is the pimple foam, it solves incompressible flows using the pimple algorithm. And then there's the simple form, which solves using the simple algorithm. So all the other solvers are named quite intuitively based on the purpose they are bound to serve. Now, OpenFOAM has a very neat and organized file structure. So you can see that the zero folder contains the initial and boundary files. Now, there's a constant folder which contains all the constants associated with the simulation, such as turbulence parameters or the viscosity of the fluid, etc. And then there's a system file, which is where all of our simulation control comes in. So as I was explaining earlier, the 4 stages, you can see that those 4 stages can be controlled using those 4 files in your system folder. I'll just explain the FE schemes for at the moment. So if you look at the FE schemes closely, you can see that there are all these operators such as ddt, which is the dou by dou t, grad, which is the gradient, dive, which is the divergence. So all these operators needs to be discretized, and we need to actually fix a discretization scheme for them as well. So OpenFOAM has the provision to assign the discretization schemes for each of them. And such level of control is not yet to be seen in any of the commercial software available, at least not the popular ones. So this would be the Navier equation, one of the most famous equations that be solved using CFD. Now, this linear application has four of the most commonly seen operators in any partial differential equation: the time derivative, the divergence, the gradient, or the Laplacian operators. Now, OpenFOAM allows these operators to be written in your source code in a very intuitive way. So there's DDT, there's Laplacian, there's grad for gradient, there is div for divergence, there's DDT again, and even for the weighted time derivatives, we actually have it very intuitively written after the last we can show. Now, such shorthand come in handy for the students who want to modify the OpenFOAM source code or simply understand the basic algorithm behind the solver without actually going into coding these simple operators. Now, to explain OpenFOAM syntax, as I explained earlier, OpenFOAM follows the same syntax as C++. And to explain how the programming style of OpenFOAM, let's take this turbulent kinetic energy equation. This seemingly complex and long equation just boils down to these 5 lines in OpenFOAM. So if you just look at the first term in that code, you can see that the dou k by dou t term, it just boils down to a ddt of k. Similarly, last line, which is the sp of epsilon by k. SP stands for the source term in this case. So the last term on your equation will be your source term, and it's very easily written in OpenFOAM and easy to understand as well. Now, finally, we need to view the results in OpenFOAM as well. So OpenFOAM does come with a post-processing tool, and the utility that is available with OpenFOAM is called Paraform. It uses ParaView, which is a very famous software, and it's an open source visualization application. You could also use other third-party applications as well, such as Insight or FieldView, or even the post-processing utility that comes with Fluent. Now, let's look at some of the case studies which are hosted on our website. Now, I'll explain more in detail about case studies in the later slides. So, yeah, this was a simulation done by one of our interns this year. So he took his this was a model, a CAD model which he this was a CAD model which he created for his bachelor's project, and he took that CAD model, meshed it using an OpenFOAM utility called SnappyHex Mesh, and did an CFD analysis over it, and found the flow pattern over the aircraft. So you can see the mesh generated using the SnappyHex mesh on the left, and on the right you can see the velocity contours over the UAV. So capturing shocks in supersonic flow requires high fidelity algorithms. This project, again done by one of our interns, encapsulates how advanced the compressible solvers of OpenFOAM are. Now, the project, again from one of our interns, analyzes the shock pattern due to the supersonic flow over multiple wedges. Now, the experimental results on the right can be seen to be closely agreeing with the OpenFOAM results which our intern simulated on the left. So you can clearly see how well they agree. Now, finally, this was one of the case studies done by a student, Padmini of IIT Bombay. So in this project, she analyzed the flow through a constricted pipe with transverse magnetic field applied across it. And she showed through this case study how vorticities, as you can clearly see, can be brought to zero by increasing the intensity of magnetic field. Now, the application of such a study in hemodynamic research is massive. About OpenFOAM capabilities. So the plot that you see is from a study which analyzed how various CFD software performed against an experimental result of a flow over an airfoil, the NACA 4412 airfoil. You can clearly see that the results from OpenFOAM match very well with that of other commercial software. And it just doesn't stop there. You can see how the results from OpenFOAM matches closely with that of the experimental results as well. shows us how powerful of a tool OpenFOAM can be for research. We here at FOSSI, we promote OpenFOAM through three major activities: the case study project, the lab migration activity, and workshops using spoken tutorial. So the case study activity, in the case study activity, the student solves a feasible CFD problem using OpenFOAM. We give certificates to those who do this, and the students also get a URL to their work, which they can add to their resumes or any other job application. Now, to start a case study project, first you'll need to create an account on cfd.fossee.in. I'll be sharing the website details later. Then you can either propose your own problem or choose an existing one from one of our available case studies. And yeah, when you submit your proposal, you will have to submit a one-page abstract as well. This abstract would be reviewed by us, and you'll be notified if approved. And you will have roughly around 3 months to complete the project. And during this period, we will be available to take all your technical and non-technical queries. Once completed, you can submit your OpenFOAM case files and the report on our website, and we'll review your files and report and notify you if any changes are required. Else, the project will be deemed completed and will be published on our website. And once published, you will be receiving an e-certificate and a link to it as well. Then we have our lab migration project. So we help lab courses which currently use commercial software such as Fluent to switch to OpenFOAM. Now we provide detailed solution to all the CFD lab problems in the using OpenFOAM. And by detailed solution, I mean we actually have detailed instruction sheet as to what is to be clicked, where the files are located, etc. And and we have been actually doing this for one of the design labs in the Department of Chemical Engineering, and for the past 4 years actually. And the last year we were there, we actually assisted students and stayed with them for the first 2 to 3 weeks to guide them through all the challenges they might be facing with the new software OpenFOAM. So lastly, we have our workshops. So we conduct workshops for both beginner and advanced users of OpenFOAM. The training program is an extension of the spoken tutorials on OpenFOAM, and all participants of the workshop are provided with a certificate as well. And yeah, so to conclude, I would say OpenFOAM is a free and open source CFD software with wide range of solvers and extensive control over them. The source code is very easy to read, and we can modify them very easily, making it a very effective CFD tool. And last but not the least, in these uncertain times when research will most likely suffer, we can take a small burden of it by switching to such powerful open source software. So I'll now leave you with this quote by Linus Torvalds, the creator of Linux systems. And I'm not sure I have enough time to take questions, but if you do have any, please visit us at cfd.fossee.in to know more about our activities, or you can write to us at contactcfd@fossee.in. So thanks a lot for listening to us. And yeah, before I leave, this would be our the QR code for the feedback form. So it's a very small questionnaire that can be accessed through QR code, and you can see it on your screens. Your feedback would go a long way with us. So thank you so much for your time, and we hope to hear from you soon.
Hello, are there any
Hello.
questions from the participants? Hello, then the next presentation will be on DWSIM, which is yesterday Kanan sir had talked about it in his presentation. Hello, am I audible?
Yes, yes, ma'am. Yes,
Yeah,
ma'am.
yeah. It is a software which Professor Kannan is actually heading the team, and it is a chemical process simulator. And to talk about the DWSIM software, I will invite Mr. Priyam Nayak, who is a project manager in the FOSSI team.
Yes, Priyam, you can say it now.
Sir, please make
Yes.
Priyam. Yes.
Yes, yes. I think I have already made. Thank you.
Yeah, I'll just share my content. All right. So, okay. So, can you see my screen?
Yes, we can see your screen.
Okay. Thank you. So, I'll start with my presentation then. Good evening, everyone. My name is Priyam Nayak, and I am one of the project manager for FOSSI project. The software which I'm going to demonstrate today is DWSIM. So starting with DWSIM, I'd like to first talk about a few points about DWSIM, and then probably I'll move to the activities that we have under DWSIM. So DWSIM is an open source chemical process simulator. It has been developed by Daniel Wagner, who is also a process engineer at a semi-national multinational corporation, semi-public multinational corporation called Petrobras in Brazil. He's a Brazilian, and that's how the name DWSIM has come from, Daniel Wagner Simulator. Its promotion is being taken care of. I mean, the promotion for this software is done at a large scale by FOSSI IIT Bombay. And for this software, the efforts are led by the PI of this project, Professor Kannan himself, who you have already listened to yesterday. Coming to some of the technical points about DWSIM, it's a multi-platform software, so you can install and run this software in Windows, Linux, Mac, and also in your Android and iOS mobile phones and iPads as well. To use it in Android phones or iPad, there are some limitations. I mean, all the features are not available free of cost, but when it comes to using it in your laptop, it is all the features of the software which comes with DWSIM are available free of cost. So it's a multi-platform software, and it's a Cape Open compliant software. So I'd just like to focus, take a minute to talk about the Cape Open compliant feature of DWSIM. Cape Open stands for Computer Aided Process Engineering Open Standards. By virtue of making a software Cape Open, basically DWSIM allows interaction between two different softwares. So let's give an example. Let's take an example. You have software called as ChemSep, and then you have this software called DWSIM. Now both these are chemical process simulators. Okay, and since both these softwares are Cape Open, DWSIM can make use of ChemSep's unit operation, ChemSep's thermodynamics, ChemSep's compounds, and similarly, ChemSep can make use of DWSIM's thermodynamics, DWSIM's unit operations, and things like that. Okay, so that's the advantage of making a software Cape Open compliant. And in the modern days process simulator, this is the need of the hour. Every chemical process simulator wants to be a Cape Open compliant software, and DWSIM is one of those. And also, I'd like to inform you that in 2012, Daniel has won the award from Cape Open organization for making DWSIM as a Cape Open compliant software. Coming to next, DWSIM performs steady state and dynamic process simulation. So earlier, when we had our version 6, DWSIM was only a steady state simulator, but now DWSIM can perform dynamic simulations as well. Of course, with limited, facilities. Not everything is dynamic right now because it's just a month back that Daniel has launched the the dynamic capabilities of DWSIM. So we are still Daniel is still developing and working on making it completely dynamic. But yes, there are certain unit operations which are dynamic in DWSIM. Coming to the compound database, DWSIM has got a lot of open source compound database. One of them is obviously ChemSep, as I told you, because of the Cape Open compliancy, DWSIM can make use of the ChemSep's compound database. And then it has database of CoolProp, it has database of electrolytes. Okay, so when I give you a demonstration of the software, I'll just show all of this to you. Okay, and then you have different unit operations on DWSIM. Different thermodynamic models. I mean, these are pretty much whatever is available with different chemical process simulator. I mean, whatever you can find with Aspen Plus, you will find all the unit operations working with DWSIM as well. Okay, and then there are different tools and utilities, like to calculate binary phase envelope, utilities to do pressure, safety valve sizing, to do pressure vessel sizings, and then tools like petroleum characterization, optimization, sensitivity analysis, things like that. Okay, so these are some of the features of DWSIM. Coming to what we offer in DWSIM, FOSSEE offers quite a few resources in DWSIM. As it was pointed out yesterday by Professor Kannan, that one of the drawback which people have pointed out about the open source software is the lack of resources and lack of study things like that. How to learn and how to use. They don't have any guide. So the projects Spoken Tutorial and FOSSEE has one of such projects which have solved that problem. So we have spoken tutorials on DWSIM, first of all, which is self-learning audio-visual tutorials which can help you to learn the software by yourself. Okay, Professor Kannan has already told you in detail about how to use the spoken tutorial technology to learn different softwares. And we have about 20 spoken tutorials that are available in DWSIM. Okay, I'll just take you to the spoken tutorial website of DWSIM, where you can see all these softwares. I mean, all these different tutorials. Okay, so here is the spoken tutorial page of DWSIM, where you have different tutorials on how to create a material stream, how to use distillation columns, how to use different reactors. You see PFR, continuous stir conversion reactor, Gibbs reactor, shell and tube heat exchanger, binary phase envelope, how to use absorption column, how to do custom modeling, things like that. So we have in total of 20 tutorials, and we will still keep adding some more tutorials for dynamic simulation. We don't have any tutorials for dynamic simulation right now, but yes, we are working on it, and we'll soon add tutorials on dynamic simulation in DWSIM. So this is the learning material that is available. Another important resource of DWSIM project, which is a flowsheeting project. Now, as you have heard about textbook companion project yesterday, that textbook companion project, in textbook companion project, we asked students and faculties, participants to basically code for the solved examples. Similar activities available in DWSIM. You have chemical engineering textbooks or journals where you have process flow sheet. And typically we ask the students, faculty, engineers to create those process flow sheet, to simulate those process flow sheet using DWSIM. Okay, so that is what is the flow sheeting project. You take a flow sheet which can be from any project report or textbook or journal, and then you rebuild the flow sheet using DWSIM. Okay, and the process, the project is open to students, faculty, and practitioners. Everyone can participate in this project. The only thing is that you should just have the basic understanding of the chemical engineering mass and energy balance concept, and have some kind of understanding of all these unit operations and thermodynamics. So faculties from chemical engineering and allied fields like petrochemical and industrial biotechnology and so on, they can contribute to the project, and they can also encourage their students to come and participate in this project. Okay, and you get certificate for the project. Okay, so details of the project are available in this website. Currently, we have about 173 completed flow sheets in DWSIM. We started this project in 2017, the flow sheeting project, and right now we have about 173 flow sheets in DWSIM. which is there in different areas, starting from reactive distillation to pressure swing distillation to a typical process flow sheet, synthesis flow sheet for plants, power plant cycles, things like that. So I'll just take you to this web page where all these completed flow sheets are available in DWC. Yeah, so these are the completed flow sheets that are available in DWC. Okay, different completed flow sheets, and we have participants now coming in from outside India. Participants outside India are well contributing to this project as well. So I request the faculties and also tell them that please encourage your students to contribute to the project. Okay. Now I'll not demonstrate of the flow sheeting project here. Rather, I'll show you something on the DWSIM software. Okay. So this is what you see now is my DWSIM software screen. Okay, this is the DWSIM software, and when you open the DWSIM software, this is how the UI looks like. Okay, you have process modeling, compound creator, data regression, things like that. And on your right hand side, you have something called as FOSSI flow sheets. So actually, the flow sheet that you contribute to our DWSIM flow sheeting project, they are also available as a part of DWSIM software on the real time. Okay. So as you submit a flow sheet and as we review it and it gets approved from our side, the flow sheet is available with the DWSIM software. Okay, so you can see about the project, it is there, and all the 173 flow sheets that I just showed you, all the flow sheets are available here as a part of DWSIM software. Now I'll just open one of the flow sheet and just show you, walk you through the DWSIM software, how DWSIM works and things like that. Okay, so if I just click on this flow sheet, which is about ethyl lactate synthesis using reactive distillation, it takes me to, it gives me a pop-up, and you can see that there is a title, and it says that what is the author name and institution and all of that. Okay, so who have contributed the flow sheet? It's someone called Paritosh, and he's from BITS KK Birla Goa campus. Okay, so if I just click on yes, it will take me to the, it will download the flow sheet and it will open as a okay, so somehow this is stuck.
Hello?
Hello?
Is
Yeah,
there any
sorry.
problem?
No, it was stuck. Now it's coming up. Sorry.
Okay.
Yeah. So as I clicked on the flow sheet, you see the flow sheet got downloaded, and there is a PDF file that opens automatically with the flow sheet. Okay. So every flow sheet is accompanied with the abstract, which roughly talks about the flow sheet, what this flow sheet is about. So you can find details about the flow sheet here. You can read about the flow sheet, and it will also take you to the reference that is from which source the flow sheet is taken. So it is probably taken from one of the journal papers. Okay, and now if I just go to the software, here you can see the flow sheet. Let me just maximize my screen. All right, so this is how the DWSIM software looks like, the flow sheet that I just opened. And you see, as I was talking about Cape Open software and making use of ChemSeps simulator in DWSIM. So if I just click on this Cape Open object editor, it opens the ChemSep window. Okay, so this distillation column that you see here is a ChemSep distillation column, which is used in DWSIM. Okay, and so if I just click on simulate and solve flowsheet button, and it starts simulating. Okay, so this is on the DWSIM software, the flowsheeting project. Okay, so if you see as it ran, and it went from red to blue. I'll just solve it once again so that I can just show you. Whenever it is solving, everything is in red, and as soon as the solution is complete, the whole flowsheet will turn into blue. You can see slowly it is turning into blue. And finally, after it is solved, it will say that, what was my execution time. It took 8 seconds to solve the flowsheet. Okay. So moving on, then we have DWSIM flowsheeting project. After the flowsheeting project, we have custom modeling project. Okay. So custom modeling project, we invite, again, it is open to student, faculty, and chemical engineering practitioners. You can create custom models in DWSIM. So basically the unit operations which are not available as a part of the built-in library of DWSIM, you can create such unit operations in DWSIM using Python or Scilab. Okay, so those of you who have worked with Aspen, you might know that Aspen make use of Fortran, okay, to create custom models. And in this technology, in today's world, I mean, it is very rare to find someone teaching and learning Fortran. Okay, but DWSIM being the new age software, it makes use of Python and Scilab to do custom unit operation development, which is very much easy to learn and to do the development. So and you easily find the tutorials on Python and Scilab in general, and we also have tutorials on how to develop custom models using Python and Scilab. So if you go to DWSIM spoken tutorials, you will find there are 2 spoken tutorials on how to create custom unit operation using Python and Scilab in DWSIM. Okay. So we just recently started this project, and I'll just take you to the project page once again. Okay. So here is the custom modeling project. If you click on this, it will take you to custom models and completed custom models. So these are the completed custom models right now. We are in the we are in the process of adding more custom models. So I once again request the faculties and ask them to encourage the students to come and participate in the custom modeling project. Coming next, we have lab migration project. So as a part of lab migration project, probably my colleagues who have presented earlier also spoke about the same, that if you have any proprietary simulation for which you run lab in your institute, and right now during this COVID times, it might be difficult for students to access the lab through the proprietary software. Even though you have official license, it will be difficult for them to access lab. It is set up using DWSIM or Unisim or ChemCAD. Okay, and therefore we have lab migration project where we encourage faculty to migrate their lab from proprietary softwares to DWSIM. Okay, recently, not recently, 2 years back, we migrated our own design lab in IIT Bombay to DWSIM, which is once again run by Professor Kannan. He is the instructor for that course. And the lab, if you can just go to lab migration project, and I'll go to completed labs. You can see that design lab 1, which is at IIT Bombay, which is by Professor Kannan. Labs are available here. So these are the different experiments, or these are different simulations that are done in the lab. So you may take a reference of this simulation and see, if you have a process simulation lab, you can contact us and we'll help you to migrate your labs to DWSIM. Okay. At the end, I just touch upon this upcoming workshop on DWSIM. Professor Kannan already spoke about this yesterday and today as well, some time back. So we have an upcoming workshop on DWSIM, which is happening on 25th August and 29th August. The advanced workshop is on 25th August and the beginner workshop is on 29th of August. Okay. So for beginner workshop, anyone can come and participate in the beginner workshop. By anyone, I mean to say, obviously, he needs to know the chemical engineering basic concepts. Okay. And for advanced workshop, you will have to qualify for that. We will assign a flow sheet to you for solving. And once you solve a flow sheet and it is approved by us, we will invite you to attend the advanced workshop. If you don't qualify, if you find that if your flow sheet is not good enough to qualify, you will be moved to the beginner workshop. And the link for workshop is available here. Okay, so I'll just put this link in the chat also after I'm done with my presentation, so that if any of you are interested, you can visit, and you can also circulate the same with your students. So this was about my presentation in DWSIM. I would so for if you have any queries, you can ask me right away, or if you have anything coming up later, you can shoot me a mail in this email ID, contact-dwsim@fossee.in. So I'm available, and I'll be responding to your mails if you have any query. So at the end, I'd like to just say that please provide your feedback, at least for the chemical engineering faculties. If you are interested, there are 2 feedback questions available in this QR code. Please scan the QR code, or you can make use of the quiz password to provide us the feedback in the Save tab. I'll continue to display this for next 30 seconds. Meanwhile, if there are any questions, I'll be happy to answer. Hello.
Yes.
Yes, sir.
So I am also checking. I think there is. Can we simulate material synthesis? The Chandra Devi wants to know. Material synthesis.
Sorry. Can you just repeat once again?
Can we simulate material synthesis?
Material synthesis. Okay. If you are talking about material synthesis, as in synthesis of chemicals and things like that, no. Probably this software DWSIM is basically used for plant simulation. So let's say you have a plan to develop a certain chemical, and you want to simulate that plant using some kind of software. So DWSIM is the one for you. Okay. So yeah.
Thank you, sir. I think there are no more questions as of now.
Okay. Okay. Thanks. So I'll hand over the session to my colleague, Mr. Kushal Singh Rajput now, who will take you through focal.
Sir, please make Yash as the presenter, and Kushal will speak. Right, Yash?
Hello.
Okay, I will make it yes. I have made it Kushal, but I will make it
Yes.
yes.
Kushal, are you going to share your screen, or Yash is going to share?
Yes, I will going to share my screen.
Okay, let us try. Yeah.
So please give me access to share my screen.
Okay, sorry, sir. Then please give the access to Kushal itself.
Okay, okay.
Yeah. Thank you, sir.
Okay. It's Kushal.
Hello.
You can share now. Yes, Kushal, I think you can share now. Yes.
Yes. Now you.
Yes,
see
we
my
are
screen?
able to see you. Yes.
Kushal, can you? Yeah.
Yes, you see.
You are
see,
audible.
Yes, I am audible also. No? Okay. Actually, now this is a short introduction of focal. Focal is nothing but a free and open source creative art library. This is obviously by the name you comes to know that this is something related to graphics designing and animation. So it is just like a portal of open source graphics and animation software, which can be used for computer graphics designing. From this portal, you can get a links for tutorials of graphics and animation software. These tutorial links quoted you on spoken tutorial for respective software. You can find skits, blogs, activities, etc. in this portal. On this portal, you can find categorized artworks, 2D, 3D animations artworks, 3D models, and templates for graphics, which are created by using the open source softwares like GIMP, Inkscape, Scribus, Blender 3D, and Synfig Audio. So I'm taking you to my portal. Please check it. So this is the portal. This is a focal portal where you can see wait a minute. So this is the portal where you can see these are the links from where you can get the templates and artworks. Suppose you want to, suppose you go to this Inkscape, so then you will get the library of these Inkscape. So these are the artworks created in the Inkscape. So you can download it, use it without any copywriting issue. So this is very benefit to all. So suppose anybody wants to do artworks in this Inkscape and he don't know how to use the Inkscape, so he can download it, these templates, and open it into Inkscape and edit it as per is needed, as he needed. So in this library, you can see, I will show you one artwork. So this is, suppose this is a resume one. Suppose you want to download that. So click on this. So here you will get all the information about this artwork. So you can check. Hello. You can check the tutorial for the Inkscape here. You can download the Inkscape from here, and also you can edit, download this editable file from this. So you can download the template from here and you can edit it. So I am showing one skit how to edit this. So this is the
all right. So when you download this template, this is what you're going to get. If you try to click on any object, nothing will happen. This is because all the elements in this project is locked in various layers. So in order to unlock these layers, first you need to go to layers, layer menu, and choose the layer option. You will get the layer side panel. Here you can see all the 3 layers available. So first I will show you how you can change this profile picture. Just unlock this profile picture layer by clicking on this padlock icon. Just click on it once and it will be unlocked. Now you can select this image as well as an underlying white object. So what you're going to do is you can first you need to delete this sample image and import your own image. Consider this is your image. Just drag and drop and it will just appear in the project. Now you can resize it to your desired size and position it perfectly. Once you have done that, just hit on page down so that it goes underneath the white object. Now you need to select both these objects. Just click on one object, then hold shift and click on the next object so that both objects are selected. Now right click and choose set mask. Now your profile picture will be masked inside that white object, giving this particular graphic effect. So if you are satisfied with that, just you can lock this profile picture layer and move on to the next part. Now I'll show you how you can change the text. So basically, just go to the text layer and unlock it by clicking on the padlock icon. And once you're done, basically you can do anything. Just double click on the text element and the text editing layout is enabled. Basically, you can just change the name. If you want, you can change this font. You can change the font type. You can change the font size. All the available things. You can change the alignment, spacing, everything else. You can do all the things you like. This is you can do this for all the elements, all the text elements in this template. So once you are done with all that, you can just lock the layer back and call it done. Now to export it, just go to File and choose Export PNG image. That in this particular sidebar will appear. Choose Page so that you can export the whole page. Then select the appropriate DPI. 96 is appropriate if you are going to use it for web. 72 is appropriate if you are going to use it for web actually, and 300 if you are going to print it. 300 and give a file name as well as a location to save it and click the export button. So that's basically it.
So now you saw that how we can use the template of Inkscapes. So there are many templates of Inkscape. So this is a GIMP. GIMP is one of the software who is manipulating and editing images. So this is one also one I want to share this one. So how you can edit the photos in GIMP. These are the proprietary softwares, as good as a proprietary
how you
softwares.
can use the passport size photo template pack. So to create your passport size photo, you should use this template over here, passport size.xcf. You should open it in GIMP. So once the project loads up, you should import your photo. Now you should scale your photo. You can turn down the opacity of your layer so that the underlying reference layer is visible, and use the reference layer to line your photo and scale it perfectly to the size. Now you can delete the reference layer and bring back the opacity to 100%. So now your passport size photo is ready and you can print it. Now if you want to print multiple photos in an 8x12" paper, to do that, go to File, New, and set the dimensions to change to inches first. Change the dimension to 12 inches wide and 8 inches high. Change the resolution to 300. Click OK. Now go back to your passport size photo and go to Edit and choose Copy Visible. Go back to the new document, then choose the bucket fill tool and choose the pattern fill option. Choose the first option, that is a clipboard image. Then click on the canvas. So now you can print this and you can get multiple copies of your photo in a 8x12" paper. So now if you want to print in an 8x10 paper.
So I am now stopping this video. Now you comes to get idea how to use these templates. So there is a tutorials how to use these templates, and you have to download the editable files from here. Open that software, open into that software and edit it as per your need. So we have so many artworks which are created by the contributors and published on this focal portal for open source community, using for open source community. And these are, there is no any copyright issue to using them. So for your need, you can download these artworks, you can use it for your presentations, for your contents, for your educational contents also. So graphic is a need everything. And one more I am showing you, this is a Scribus. Scribus is a desktop publishing software, which is also one of the open source software, which is a desktop publishing software. In this software, you can use newspapers, you can create a newspapers, you can create a brochures, you can use for any letterheads, any DTP kind of publications, you use this. This is very best software. These are the softwares which are compatible with the proprietary softwares. I will share you within a moment the softwares which are the proprietary softwares, and as good as instead of that software you can use these softwares and you can get a best result as good as that softwares. So this is a Scribus library. So you can go here, you can after that you can download these files from here, and you can download the version of the Scribus, and you can watch the tutorials also. And all the tutorials links, basic tutorial links is from spoken tutorials. So suppose now this is a Blender. I'm going to Blender. Blender is a 3D animation software. So the contributors are already shared their 3D models and their animations here. So you can download it, you can manipulate them and use it. And you can learn this software also by using tutorials. I will share you this one. So this is made in Blender 3D, and this is created by Ravi Kumar, yes, which is one of our fellow of FOSSI Summer Fellowship. So this kind of Blender animation, you can download its original file from here, from this link, and you can, if you want to watch the tutorials of Blender, you can use this link. And if you want to download the Blender version which is used for this animation, you can use this. So if you want to see the tutorial, then you have to click here. It will takes you to spoken tutorial. Sorry, this is a Blender download, and this is the tutorials. From here you can see all the tutorials in different languages. So there are too many languages, so you can choose any language and you can learn the Blender. So this Focal is actually as a portal. It has many links for the tutorials, the works, for the softwares downloading. And one more 2D animation is there, 2D animation software. This is Synfig Studio. This Synfig Studio is a 2D animation software. This is also open source. I will show you one animation which is created in Synfig. This is a balloon falling from staircase. So these kind of animations, designs, drawings, you can create in the software using the software Inkscape, GIMP, Scribus, Blender, and Synfig Studio. These 5 softwares are open source softwares, free softwares. And now I will share you a table. So before that, these softwares are very powerful softwares, and there is a, you save your money, you will get support from community, which is always available on internet, and it is also secure also, and these are very user friendly softwares. So Inkscape, you saw that for Inkscape is for doing vector designs, diagrams, and illustrations. And GIMP is widely used for image manipulation and image editing. This is a Scribus, which have a support of CMYK support also. So any offset printer wants this support. So Scribus is also support for CMYK color and spot color also. And you know these 2 softwares, Blender 3D and Synfig Studio. Blender 3D is for animations, 3D animation software, and Synfig Studio is 2D animation software. And Blender 3D also have one great feature from where you can edit your videos. So it has its own utility, so video editing utility. And this is a table of comparison table, proprietary software and open source software. So whatever you want, you are going to do in proprietary software, you can do in open source software. Suppose Adobe Photoshop is as good as GIMP is as good as Adobe Photoshop. Inkscape is as good as CorelDRAW and Adobe InDesign. Scribus is as good as PageMaker, Quark Express, and Adobe InDesign. Blender 3D is compete with the Maya and 3D Max, and Synfig Studio is as good as Adobe Flash. So these are the comparisons. So these portal, actually these Focal is contributed by the contributors, and it is growing up when the contributors share their artworks for the open source community. They have to use these open source software and create their artworks and upload the artworks here, so anyone can use it without any copyright issue. So I am sharing you one. This is a feedback screen. You can give a feedback and take a quiz. So hello.
Yeah, you are audible.
Yes. So I will share that feedback screen once again, so you can take a snapshot. Yes. So this focal is our objective is there to encourage the student and entrepreneurs to use open source software in computer graphics. To promote this learning open source software, open source graphics animation software, we are trying to come up with some activities like contributing to this software, contributing your artworks on this focal, and also fellowship also we did.
So
Yes.
thank you, Kushal.
Thank you.
So if there are any questions for Kushal, please you can go ahead and ask.
I think not. I think one participant, Dr. B.R. Panchal, he is asking that any good software which is free and we can use it for a video editing.
Yes, I already told that the Blender 3D is a ability for video editing. This is also free and open source software. You can edit your videos in that using Blender Studio, Blender 3D.
Okay. Thank you, sir.
Thank
I
you.
think probably, sir, QR code is having some issue. I think that they are asking about that it is expired or not, I'm not sure. So,
No, actually it is a current quiz only, so it is not expired. Only thing is that for Android phones, the QR code works fine. You have to first go into the Safe app and then scan the QR code. So then it will work. And for the iOS phones, you have to use the quiz code and the course code to access the quiz. So if there are no more questions, we will.
ma'am, I think.
Yeah, I saw that QR code is expired on Android too. I will just check and get back. I will just go and see the interface, but actually it's a ongoing running quiz only. I will just check and update on the chat window. I will do that. Okay, thank you. So shall we move on to the next presentation?
Okay. Yes, ma'am. Yes.
Yeah. So next presentation is about OSDAG. It is a software which is actually developed by our FOSSI team at IIT Bombay. And the PI who actually takes care of this activity is Professor Siddharth Ghosh of the Civil Engineering Department at IIT Bombay. And Mr. Danish Ansari, who works in that team, is going to say the details and give you a glimpse of OSDAG to you. So over to Danish, but please make Yash as the presenter.
Yes, okay.
Yeah.
So I have a comment to add. Even if the QR code is not working, Priyam has sent in the chat window the code and the password. Using that also you can enter in case QR code has a problem. Just check the chat. I saw Priyam sending that information.
Okay, sir.
Just to add,
Hello.
one second, Danish. All the exams are still running, so it doesn't have any problem. Probably it may be some connectivity issue you are facing.
Hello. Am I audible?
Yes,
Danish, you
Danish.
are. Go ahead. Thank you. Thank you, Shaman. So, good evening, everyone. My name is Danish Ansari, and I'm from the OSDAC team of FOSSI. So, OSDAC is basically open source steel design software, which is based on the Indian code IS 800 2007. And yes, next. So, what I'll do is I'll briefly talk about steel and steel structures and what are the challenges that we are facing in India with regard to the course and curriculum, technological challenges. And then I'll give a short demonstration of OSDAG and how it works. So, this is the lineup of today's presentation. Next slide. Next slide. So here you can see a steel cantilever steel bridge, and this is in UK. And the thing what we should notice is that this bridge is 130 years old, and it's still in service, and it's a railway bridge. So you can see the life of structure as 130 years, which is not possible with any other building material. Next. Again, this is the very famous Empire State Building. This is more than 100-story high. And what we can see is that it took only 14 months to construct this building, which is more than 100 floors. So again, this is only possible when you use steel as the construction material. Next slide. This is the King's Cross railway station, which was built for the London Olympic Games. And you can see it's covering huge space without any obstruction, without any column in between. So just imagine if there was concrete used over here, and you could have all columns all over the place, and it wouldn't be as aesthetic as it seems now. So next slide. So I can keep on showing images, but what I want to say over here is that steel as a construction material, it's close to an ideal material, and it has a lot of advantages. As we all know, it has very high strength to weight ratio, which will reduce your material and carry more forces. It will give more space and flexibility for construction. You can do prefabrication so that you get better quality control. And again, you can see that it could be recycled up to 95%, which is great. You know, these days we go for clean construction and worry about the environment. So this is one big advantage which steel offers. Next slide. So now we'll look after the stats related to India. Next slide. So this slide over here shows that we are second largest producer of crude steel at 106 million ton. This is figure from 2019-20, and which is great. We are capable of producing a lot of steel. Next slide. But when we see consumption and when we compare to other developing or developed countries, so consumption is very less. You can see we only consume 70 kg per capita against world average, which is 225 kg. So there is a huge margin over there. And also steel to cement ratio is very less. So basically in India, we construct more with reinforced concrete, and there are reasons for that. And there are basically policy level reasons, technical challenges, technological challenges. So and here you can see that this is the challenge in front of steel ministry to increase the consumption. So what they project is 300 million ton production and also 160 kg per capita of consumption by 2030. So from 70 to 160 kg in 10 years. So this is a huge jump which we will take, and it needs a lot of efforts. And there are challenges, as I said, and what we are going to do through OSDAG is we are going to address the technological challenges mostly faced by students and young students of college and teachers who are teaching steel design in their course. So there are various perspectives, but what I'll take is in design engineer or student's perspective. So there is a general feeling that it's steel design is very complex. There are a lot of codal provisions and checks, design checks which you need to satisfy, and also detailing checks which you need to satisfy. So there are too many specifications, as I mentioned in the code. And the steel design courses, if we leave out IITs and most of the NITs, the steel design courses are not that well equipped to create trained human resource. So it's just a textbook based learning and very less hands-on experience is not provided to students. So we don't create trained human resource which are skilled enough, and that is very important factor in reduced consumption of steel. And again, there are no free tools or resources available, absolutely not there. You have all the proprietary tools, and these are very very expensive, and so students don't get the experience to use the software, and it hinders their learning. So due to these reasons, we are not that confident with steel design as with RC. Next slide. So next slide. So what was motivation for us to work on OSDAG? So the design codes which got revised in say in Western countries, US or UK or Europe. So the softwares were made available very easily and quickly. But when we have a code revision or code is published in India, we have to wait for years for Western countries to develop software based on IS code and then give it to us, and then we purchase and use it. So this takes a lot of time. So the IS code, which was published in 2007, the softwares were available mostly after 2012 and 14, as per my knowledge. So that is huge. And yeah, so these softwares are very costly, and only big firms can afford to purchase license of these softwares. Even colleges sometimes they most of the times they don't have license, and this results in piracy. So people go for cracked using cracked version of the softwares, and which is not an option. It's a criminal offense. So and people who refrain from both of these, they rely on in-house solutions like spreadsheet and maybe hand calculation. But these are okay, but these are not very efficient. It doesn't teach you much. So it's like a black box where you just see some numbers. So considering this, what we thought is if we can develop a software which is of course free and open source, and which can be disseminated easily among students with resources, and then if they can use this, they'll be able to get hands-on experience with this software, and they'll come out as better designers, and hence they can push the stats up of steel consumption. So just can you move to the demonstration video? So I'll just give
Okay, just
one.
a second.
Thank you. I'll just give a demonstration of one design module in OSDAG. So we'll consider a tension member design, which is taught in all the curriculums, third year steel designing course. Yes, thank you. So this is the main window of OSDAG. As Ushama mentioned, it's developed by Faucet from scratch. You can see on the left side, you have various design modules. You have connection, you have tension member, you have compression member, flexural member, you have beam to column, plate girder, truss, frame design, and group design. So everything is there. So yeah, we'll see in connections. So again, they have sub modules. We have shear connection, and in that we have 4 types which are most commonly used in construction. We also have moment connection. In that we have beam to beam connections. Again, we have again the most common ones. We have beam to column connections. These are end plate connections. These are like very common. We have column to column connections using cover plate and end plate, both welded and bolted. And moving on, we have base plate connections. Again, this is again taught in the curriculum. So yeah, this is also there. Some modules are missing. These are under development. So we'll go for a tension member demonstration. So we have bolted and welded connection. So we'll just go with a bolted member design. So you just click or choose the member and it will highlight and you say start. So this is the design window of OSDAG once you say start. And you can see it's divided into 4 parts. You have the input dock on left. Here you have the CAD window which will display a 3D CAD model. Below that you have a log message window which will give messages related to design. And on right you have output dock which will display all the output values. So here you have and you have some menu options to choose from. So what we'll do is we'll design a tension member and the section profile will define. So these will start giving inputs and you can see we have different section profiles. We have angles, we have back-to-back angles, we have channels, we have back-to-back channels. So we'll just choose one, say back-to-back channel, and you can see a representative image being displayed. You can choose the connection location. Here it's simply web, and you have to define a section. You can either go with all the available sections or you can define a custom section. So once you click, you can see a list of sections given by IS 808 and it's all selected. And if you wish to choose a few specific sections, you can do that as well. So once you select, you just say submit and it will be chosen. Again, moving on, we define the material grade. Again, all the material grade listed by IS 2062 is available. You can also define a custom material. We'll simply choose one E250, say, for our design. We'll give length of member as 3 meter. And now we define load, so let's say we'll give 500 kilonewton. Now we need to define bolt. So either you can choose all or you can customize as per your needs. So you see where the various diameters it's listed there. You can choose from bearing bolt or friction grip bolt. These are the two available choices. And again, in property class, it's same. You can choose all or you can customize the grade as per your requirement. And same for plate. So the once you enter the inputs in input dock, so you can see a design button. You can press the design button, and within a few seconds, it will give you the design. So once you see the CAD model, it means that the design is successfully completed. You have log messages down over there. You can rotate the CAD model and see from various angles how it looks. You can zoom in and see the details. This is very great when if you're taking class and you use this. It's very helpful for students to visualize what they're actually designing. So CAD model is very helpful in that way. Again, you can see the various views. You can see the top view. You can see the view from side, and you can see the longitudinal view as well. So here you have the message window. So all design log messages pertaining to design will be given over here, and it has a reference of the clause and IS code which it refers. So this again, it's in learning capability of user. So it says that design is safe, and hence we have the CAD model. And on the right side, you have all the output values. We can see section details, and this gives the optimized result. So you don't need to further optimize any of these. You have the capacity calculations. Then you have the pattern. So yeah, you have a representative image showing the block shear failure. you have the efficiency of the section. Again, the end connection details are displayed. So the diameter and grade, all the outputs are there. It gives the block shear of, it gives the spacing details, which is essential for fabrication. It gives the representative drawings, so it's easy to understand. So here it is. Here it gives the gusset plate details, and it also gives the block shear failure pattern of gusset plate. Here you go. So, these things I think are very important for a student learning or starting to learn steel design. So he gets to know everything by seeing the outputs, and you have more controls available in design preference. So you can see the various properties of the section is displayed, the mechanical properties, it's all there. You can choose preference for your connector. You can see the grades and the yield strength values. For bolt, you can design give the preferences. You can choose the hole type. Again, for detailing, you can give preferences. So once you give preferences, you say save and you can design. So we also have design report, something which is very important. And when you say create design report, it will just pop up a window and ask for few details. You just fill it out. Yes, can you forward it by 15 seconds or so? More.
Yes, please go ahead.
Please forward by 15 seconds the video. Okay, fine. So you just give the details of your report and just say save, and you have the design report over here. And you can see all the inputs are echoed in your design report, whatever. Yeah, you can see the input parameters. So everything is there. Unlike design reports of commercial software, which is very difficult to understand sometimes. So it gives the considerations and assumptions, and everything is there. So by referring to design report, you can just learn to design. You can learn the design process basically. So here you have design checks. The member which was selected, data is given, the mechanical properties and other section data. So you can see over here, all the checks are given in detail and step by step procedure wise, so that you can learn those checks. And the required values are compared with provided values, and you can see there is a remark which says if it's passing or not passing, and it gives a reference to a clause that where does that check come from, so that student can go back and learn the clause or try different values. So if you scroll down, you have everything basically. All the checks are there. It's very detailed and very helpful. So yeah, it will also give the views, 3D views and drawings, useful for fabrication, and the log messages are even, present. So yes, you can go back to the presentation. So this is the design process. This was one complete design process of a module in OSDAG. So yes, can you go to second last slide? Yeah, so I think my time is up. So next slide. So you can download OSDAC from osdac.fossee.in and try it yourself. And you can try the various design examples which we have on our webpage, and you can get back to us. So I think I'll end my talk over here. And please remember to give your feedback. It is important for us. The process is same. You just need to scan your scan the QR code and use the quiz ID and password available. And please give the feedback. So we'll just keep this slide here for another 10-12 seconds. Please consider to give your feedback because it helps in us in improving. Okay. Can you go to next slide? Okay, so I would be happy to hear from you or answer your queries or whatever you have. So please consider contacting us at contact-osdac@fossee.in. Osdac.fossee.in is the official website which for OSDAC, and you can find all the resources and materials over there. Thank you so much.
Thank you, Danish. So if anyone has any questions for Danish, please, you can go ahead. So then can we move to the next presentation, the last presentation of the day?
Yes. I have one, I think, from Susma. I think probably LSM, how to check LSM and WSM. That he.
Sir, yeah. Sir, we are using LSM. We haven't developed anything for WSM. It's only LSM as of now.
Okay. Okay. Thank you.
Thank you.
There is one suggestion from Dr. D.R. Panchal, who says that software consider amendment of IS 800. That is a suggestion for you, Danish.
Yeah, so that is what I was saying. So if there is any amendment, like we can add it over here quickly. So which is not possible for other proprietary softwares. Like it takes a lot of time. So here it's quick that way.
Okay, thank you, Danish.
Thank you.
So yeah, so today's last presentation is on QGIS. It is a software used for geographical information system, and QGIS stands for Quantum GIS, and it will be presented by Professor Pennan Chinnuswamy, who is actually a professor at IIT Bombay in Sitara. Sir, can you please make Professor Pennan as the presenter? Yeah, sir, you can go ahead, sir.
Hi, can you hear me?
Yes, we can hear you, sir.
Yeah. Am I going to present the slides or someone else is sharing the slides?
Presently, I have made you a sir presenter.
Okay, yeah.
Yes, sir. Slides are visible.
For some reason, it's going back. Okay. Can you see the slides?
Yes, sir. Yes, sir.
Okay. So I'll start now. Good evening, everyone. Welcome to the session on QGIS. So I'm an assistant professor at Center for Technology Alternatives for Rural Areas in IIT Bombay. And the outline for today's talk would be what is GIS, because a lot of introduction is necessary for this. It is not a new software, but we'll go through a little bit introduction of what is GIS and why is it necessary. Available tools for GIS, what tools and other data instruments we could add for GIS, and how does FOSSEE work with GIS, especially the QGIS, which is Quantum GIS. Activities that we do in FOSSEE and how collaborations, research, etc. can be held with FOSSEE. So what is GIS? GIS is a software which is computer based, and it's just a method to collect, analyze, manage, and clean data. So most of the data is available in different formats, but GIS prefers to allocate a geographic data to a data. So it's combination of different data and converting data into information. So basically the key words here is collecting and analyzing, because data exists in different format. A clear example is your census data, where it comes in different columns, different Excel sheets. But how can we bring them all together into one software and analyze and model them for a concrete understanding? So GIS allows you to seamlessly edit and also overlay different data sets on top of the other and create weightages of data sets. Let's see an example. So this is a database of a census data, and you can see different columns. This is how most of the government data exists, in different columns and thousands of rows. But as such, if you look at it and do the calculations and stuff, it is very hard to create some understanding. So what has happened is, if you visualize, there is a saying that a picture says more than 1,000 words, right? Is worth 1,000 words. So here you can see that the same Excel sheet, when it's being mapped into a map, you can see that a US state is there and all the different states is there, and the population is being differently colored, and all the dark colors are associated with a high population density. So you can see that all of them are kind of triangulated towards New York and other places. But this clearly gives an example for policymakers on why data visualization is much important. So how does this work? So data can come from different sources. Let's take just in the areas I work in. I work in hydrology and agriculture. We have wastewater, land records, transportation, fire, police, all are different entities of data. And these data can be combined to one information in GIS. So that is what is called Geographic Information System. So data as a number would just be less meaningful, but if it is associated with a geotag or other data sets, it becomes an information. So GIS is about converting that part. And you could clearly see here is, like in the second image, that we have different data sets, but all converted into a map. So when we have a map, all these Google Maps and everything you see, somewhere around a GIS platform is used to make these maps. It could be different overlays of GIS maps, but the base is you need a GIS tool to make these data numbers into maps and give them an association. So how do we start a GIS process? The first thing is you would create or define a problem. What is your objective? What is your aim of a study, or what do you want to analyze? So that is my definition of problem, which gets into the criteria for GIS. How much GIS weightages should I put for GIS platform? So sometimes the data you need to clean and then bring it into GIS format. So that is the defining of GIS criteria. Then you import or build data sets. It's also called a database. One data is called a data set. But if you kind of build it all together into one folder or one database, it is a massive database for GIS, right? Then you do some analysis. It's not just mapping. It's not like a Google map you see for ordering Uber or Ola, where you see a car coming and then on the map. But here you also analyze. For example, you can also tell, like, am I near? What are the near hotspots? I can turn it off, turn it on. So all this is GIS based. Then you get the output, and sometimes the output gets into more of a decision-making process. This is most important in climate change perspectives, most of earth environmental sciences or civil engineering sciences, wherein you need to take a decision based on these GIS maps and output. And most of the time, what we have seen is when you have a clear decision, the decision defines another problem. So this loop is cyclic. And GIS has that ability to keep on moving as cyclic process, wherein you create one map and then that map becomes the base of the second problem. So where is GIS used currently? GIS is used in a lot of mapping and visualization, as I said, Uber, Google Maps, etc. Transport analysis. All the transportation departments use GIS to understand where the load or how much population is there, where should I give the buses, trains, environmental impacts, climate change, hotspot analysis for accidents, like on highways, where do I place my ambulance? You could see on highways, you see all these 108 ambulances, but there are specific places where they have to keep these ambulances, and that is based on GIS analysis. Rural urban planning, where and how much water do I have to supply? Disaster management, especially in the floods which we saw recently in Odisha, Bihar, Calcutta, etc. Navigation, again, also linked with maps and transport, surveying and governance. The recent one, why are we trying to build this expertise in India? This is the concern we have, and why do we have to bring this out? Is because whenever a natural calamity strikes, for example, this is the 2018 Kerala floods. What you could see is when the Kerala flood struck, the image you see here, the Lake Vembanad, is very small. Okay, so this is before your lake got inundated with floods, and then after just one day's rain, the entire area of Vembanad is now flooded. Lakhs and lakhs of people had to be transported, and a lot of damage to the environment was caused. And how do they know it? So this map was prepared by NASA. NASA is in the US based agency. Through MIT and Harvard, these schools did it. But again, it's just a very straightforward process. If you have the data, if you have the GIS platforms, anyone can make it. But we had to rely and wait on a different platform or a different country to help us with these maps. So if we could build this capacity, then we could also address all these issues internally. This is the aim of bringing QGIS here. And QGIS, as I say, is expensive in different platforms. As you could see here, there's multiple data sets on your left. All these are different satellite-based or census-based, ground-based data. And that comes into the data hub, which is you have your Sentinel hub is your European Space Agency hub. Same, we are trying to create one for the ISRO hub. And then each one on the right you see is different applications of GIS. There are different platforms. As you can see, ArcGIS is the commercial platform, but QGIS is the free open source software, which we're trying to promote in FOSSEE. In FOSSEE, what this could help is to get more people using this software for capacity, and also to use it at a low scale resolution. For example, I don't need the Government of Indian Mapping Agency to map my village, but that work can be done at a village level, at a school level, if I could teach that software. So that is the aim of starting from the bottom of the pyramid. The GIS interface looks similar to this. This is the version 2.18, which I use mostly for classes. And you can see that I have only 4 data sets. I didn't want to get into much of the programming or the ease of using the software, because it takes a session. It's like a tutorial session by itself. And you can see a lot of buttons. It's like buttons you click, and then you enable or disable a data set. So you can have at least 3,000, 4,000 data sets on your left panel. So layers is the data set, and each one could be 1 or 2 gigabytes. So max. So what happens is you have plethora of data, and you can map it one by one among each other and create these holistic maps. The current version which is available is QGIS 3.14 Pi, just got released. And why something about platform of QGIS, it was developed by Sherman in 2002. And it was under the general public license, which means everyone can use it, anyone can use it. There's no commercial value added to it. It is a very versatile software. It runs on all operating systems, unlike the commercial ones. It can also run on apps, on your phone. So if you're creating an app and you think that mapping the data of the app to your data, that could actually help in a lot of visualization and also correcting your data. A live and vibrant QGIS community exists. This is very important. Why? Because if you have issues with the software, normally in a commercial software, you have to write to them. They have a team, internal team of working on it. But here you have a very good open source software community, which you just post the question and they try to answer it. We are also doing that on our FOSSEE website. So many public and private agencies are now migrating towards QGIS. Some of them are the US National Agency, the Australian government, Swiss regional agencies of 2 counties, New Zealand Public Department also. So the FOSSEE GIS, this brings us to what do we do in FOSSEE QGIS. I think QGIS is very young in FOSSEE, just started a couple of years, and this is how our website looks like within FOSSEE. We have resources, we have downloads where we have different data sets and which software to use. Sometimes the software is still under testing mode, so we promote the stable software. That is why I'm using not the updated software, but a less stable software. But more stable. And then we have the forum where you can have these questions and answers by us or some of my students in IIT. And then the fellowship. This is the key capstone of this, where we invite students to participate in FOSSEE activities. So our aim is to introduce and promote QGIS, not as a competition, but so that a lot of people can start using this tool. It's a very important and powerful tool. So normally, if you go to a government agency, they will have a consultant working on these maps, and a map which takes 10 to 20 minutes to make, the consultant will charge 1 lakh rupees. We've seen this a lot. And so if that can be done, the government agencies can convert all the files and books of data into maps, which is more usable. So the FOSSEE interns come from different places. Last year, we also had one couple of states, from different states. Last year we had 2, and this year we had 4. And these interns take part in QGIS activities. They define a problem, they work on the problems and create maps and reports. They also help in creating multilingual spoken tutorials. Normally spoken tutorials are available online of any software, but multilingual, because India has a diversity of languages and many different communities, it is very important to have these different languages, and that is where spoken tutorials or FOSSEE has an edge over other platforms. And it also encourages scientific research, case studies, and coding. Some people who are very interested in coding, they can also start coding in QGIS, which is not available in a commercial software. So you can also be a community promoter. It helps to build your CV, the student's CV, that you have been part of these community organizations. Training and capacity building, we are on the way of creating a lot of workshops and mapathons to build capacity with government agencies and local universities to show that this capacity exists in India. Initiation of QGIS labs, a lot of civil engineering departments and a lot of labs have come to us that they don't have a QGIS lab, but can you guide us on setting up a lab? And we have worked with them. One example is Crescent University in Chennai. And then workshops and mapathons. This is again, like I know that there is a problem in Kerala of flooding, but I may not know what is the issue in UP or what is the issue in Chhattisgarh in some local village. So this is where this colleges in the local areas can start using this software and make these maps. It could be not related just to floods. It could be for tribal welfare. It could be herbal gardens. You know, with COVID going on, a lot of people are going into this traditional medicine, but where do you source the herbs for the traditional medicine? So these can be mapped to a GIS software, and everyone can use it and understand who has access. So I'll just show a couple of case studies very quickly. The case study 1 is about estimating soil erosion. This was done by an undergrad, believe it or not. It was done by an undergrad from Pune University of Engineering. And what she did is she looked into Kerala and saw how the flooding has changed the land cover of Kerala just before and after. So the floods happened around December. So January and August, the propagation of floods was happening, or before the floods. And then after the floods, the color totally changes. So this is very valuable information, not even the government had. So this can actually help in understanding where can the government or the local authorities have management practices to reduce floodings and solid management or soil erosion management. The second thing we are looking here is the Western Ghats. The Western Ghats is known across the world as a UNESCO hotspot. It is a biodiversity hotspot. It has plethora of life forms, and there's a lot of obstruction going on in the Western Ghats, the forest. So how can we preserve this to have these boundaries and work on how it has changed over time? So then what happens is all these methods, the results and reports, whatever the students have done in the internship is being stored and shared for free in the FOSSEE website, QGIS website. So anyone is welcome to go and look into how the method, how did they collect the data, how did they analyze the data in QGIS. And then there is also some tutorials to support their work. Not all the tutorials are there because of the time, but we are keeping updating all the tutorials. So we are also happy to address these, and some of these are also going to get published in international journals. So the current case study, which was done by the current student Zeel Shah, is how to look at air quality before and after the lockdown. And you could see clearly that there is a pattern. The lockdown has an impact on the economy, but still it has a very positive impact on the air quality. All this you could not do just by having numbers from observation data stations or from the government records. You need to map it. So when you map it, you see a trend. You see these boxes of red occurring. And what are these boxes? These are the boxes where these power plants and other things are situated, and they've been overrunning or something, and so there are some emissions. But overall, the lockdown has had a positive effect on your air quality. So, but what about the data? So we don't stop with GIS itself. We also help and show where you can source the data for GIS, because some platforms have mapping as a tool, but to bring the data, you have to pay. But what we teach or what we promote in QGIS is we also give link to remote sensing data, which is free of cost. Trust me or not, these are much good quality and quantity of data available for free. And when you term all these together, that is what is big data. So by definition, big data is large amount of data coming in large frequency. So all these satellites are available across the globe, and they're continuously taking data, and it's free of charge. For most of the satellites are free of charge. The first one we're seeing here is from the US agency NASA, just for water and just for agriculture management. There are multiple satellites. This is the European fleet of satellites, around 30 to 40 satellites, which we use. And so indirectly, whatever you use on your Google or Uber or even your Swiggy to see where your guy is, it has these satellite images. So that is how everything is embedded. And last but not the least, ISRO. ISRO is having tremendous potential, and they've pushed a lot of these satellites out. And all these satellites will need a GIS platform to make meaningful maps. You can analyze it with R or MATLAB, but making maps and helping the local urban or rural population, maps are more important. And that is where GIS plays a vital role. So to sum it up, there are a lot of satellite observation networks. There is also census data, which is taken in books or in your tablets in Excel format. All of them can be archived and cleaned and used in a GIS format. There is some pre-processing and fine-tuning which can also be done. And at the end, you come up to thematic maps. Or a thematic map is something which says, is there a drought or not? Is there a flood happening or not? So all these you could see in these kind of maps. And also you have these new softwares coming called Google Earth Engine. So the Google Earth Engine is a platform where you can actually do some of these analysis and create a database from which you can download it into your QGIS. So there are some platforms existing which you don't need to understand about satellites. You just click that I want rainfall, I want land cover, or I want temperature. Please bring all these data together, and Google Earth Engine will help you. And FOSSEE is slowly also including those tutorials for you so that you can also use QGIS much more frequently. FOSSEE tutorials are now currently being set up for also these data archiving and using data. Our first preference is ISRO to promote our own organization. So we are working closely with them. So to conclude, GIS is a powerful tool to organize, visualize, and analyze data, convert data into information. I'm sorry for the wordings. QGIS is the open source software. There are multiple platforms, but QGIS is very well known across the world. And it is an open source free platform for everyone and works very well on any platform. FOSSEE provides support, training, and research, and also for collaboration between these organizations. Most importantly, what I'm having in FOSSEE is the multilingual tutorials, because there's lots of people and students who have their mother tongue as their primary medium, and these tutorials can help them for expert applications. With this, I'd like to thank the QGIS developers and community. They are all, they're not virtually everywhere around the world. So I'd like to thank all of them, the FOSSEE team members, including the FOSSEE PI, and then Dr. Snehata, the coordinator, the Deepthi, the GIS experts, the college partners who also give a lot of ideas to us on where to invest our time, and the remote sensing data platforms for giving us such important data for free. With this, I would like to have question and answers and your safe app quiz. Thank you.
Yeah, thank you, Professor Pennan. I can see there are two questions. Are you able to listen me?
Yeah, go ahead.
Yeah, the first one is asked by Ashok Jha. That is, what is the difference between GIS and GPS? It's a very, yeah, please.
That's a good question. So in a GPS, what you do is you go and take a position on your phone or a device. So it's called positioning system. So it gives you a lat long or a number that tells you where you are on the planet. Okay, and that data is a number. It doesn't make much sense unless you bring it on a map. Let's give an example. Your Uber car is standing in Mumbai airport. So that Mumbai airport has a GPS location. Unless it is converted into a map or put it in a GIS platform, then you know, okay, my car is standing in the airport. Otherwise, it will show you a number which doesn't make sense at all, for us at least. Yes.
Yeah. Another question is from Sanjay Mahar. How can we use QGIS to study mountain Himalayan ecology and natural resource management in Himalayan region?
That's a very good question. There's a lot of been done there. The most important part of why Himalayas have less data. I worked in Nepal Himalayas for 3 years. So what has happened is their remote sensing data you collect through satellites. Because of the Himalayan range and because of the transboundary tension which is ongoing now, you cannot place instruments to collect data, be it rainfall, ecology. For ecology, I assume it will be like what kind of animals, what kind of plant species, etc. So how do you use GIS? So there are multiple methods. One is you use remote sensing data to show where the land cover is, where what kind of trees are present by zooming in or zooming out. The second is you can also use your on the ground personnel like volunteers who go down on the field. They collect the GPS geoposition system, GPS location of plants or ecology, and then they come and map it. So once you map it on your GIS, then you create hotspots. For example, what we did is we would walk along the Himalayan mountain ranges and identify springs where water comes for the people. So that is the only drinking water. There is no drinking water supply to Himalayan villages. So what happens is when an earthquake happens, the springs are lost. So we go and we take a phone, we take the GPS locations, come back, map it, and then we give the family a map and a route. From your house, the nearest spring or nearest water source is 5 meters away. So go in this direction. So that is how GIS can help. Did I make sense? Yeah.
Sure. There is another question. Aruna L. If GPS are not available where we can use Android for last long data, how best will be its accuracy?
It's a good question because the cell towers, so how your Android works or any phone works is it connects with 3 cell towers instead of your satellites. So your GPS works with satellites, your cell phone works with your Airtel or Geo, whatever towers is. So the point is your instrument was not meant to be a GPS instrument. So there are some errors. The errors can be rectified by cross-checking it with your towers. The towers are very accurate systems. You go to the tower, take a GPS location, and then you share it. So it depends on the system. You cannot say how it is, but yeah, phones are not mostly used for GPS coordinates. But all of these could be checked in QGIS. So once you put it on QGIS, you overlay a Google Earth image, and then you can see that, for example, I take an image, I take a GPS of my lab in IIT. And when I put it on my Google Earth using my GIS, QGIS, if the lab is not present, then I know what is the error. It could be 10 meters, it could be 20 meters. Something like that you can do for calculation. Yes.
Okay. There is a last question from Kaveri Dabakar. Can we set up a GIS lab in our campus?
Yes. Do you need help? I think Fossey could help because what has happened is all you need is a couple of systems where dedicated systems if you want to secure the data. So some labs would have a GIS, QGIS lab. where you have at least one or two laptops and a server or a hard disk drive where you keep all the data or backing it up regularly. So anyone can start it, and it depends on your need and your budget. Even a one person can have one lab, QGIS lab, just having one system, one server, etc. So all you need is a good working computer, a laptop, and then even some people work on the cell phones. So it is doable, yes. And we could help you. You could contact our team. They will help you how to set it up.
Yes, actually, she is writing that she wants that. That's
Yeah.
a great news information.
Please
So,
see this email, contact underscore or dash QGIS at FOSSI. Please send an email. We'll help you out with it.
so Professor Panan, I think there is no questions from my side. Is there any question, Amit sir? Can you see it on the YouTube link?
No, sir. I think most of them is already answered. It has already been included, whatever you have asked.
Actually, one question is that, but it is not related to, I think, Panan sir, like some Akash Kumar has asked, is there any software for RCC design? So maybe some other members who are working in this can answer on that part.
I can answer, Danish here.
Yeah, please, Danish.
No, there is no software for RCC design. We have only for steel design.
Okay, thank you. So, so we can thank you, Professor Panan.
Yep, thanks a lot.
Yeah, for explaining this QGIS. So, Usha madam, is anything left here in this any software? I think this is the last one.
Yes, sir. This is the last one. Our team member Yash will like to just share our social media handles and a link for the feedback form. If anyone is not able to access the Safe app, then they can fill it up. Yash, can you just make Yash the
Yes.
presenter? He can flash it across.
Amit sir, please help us.
I have already made some meme. I think.
Yeah, thank you, sir. Thank you, sir.
Okay. Yes. So this is the link. I mean, we have a Google form wherein you can fill the Google form based on the interests. So I mean, based on your interest of the software. Okay, we have asked questions on different software, like just to know your feedback and your interests. So you can definitely fill it as per your interests. Okay, in a particular software. And also we have our social media links. So FOSSI NME ICT, which is a project, is very active on Facebook. Yes. Okay. Can we get all the links a screenshot? I'll paste these links in the chat. Okay, let me just try that. Just a second. Okay, I'm sharing my screen.
Yes, I have actually put the link on the
Okay.
chat. Yeah.
Okay, fine. So you can just follow our social media handles: Facebook, Twitter, Instagram, LinkedIn. Okay, we are very active on all these handles, and we generally post all our updates. Recently, we had a online Scilab Toolbox hackathon. Okay, for which the results are going to be displayed, or I mean, by this week. So we had almost around 700, more than 700 participants for this hackathon, and it was conducted virtually. We also had, as Professor Kannan would have mentioned, we also had our intern, like FOSSI Summer Fellowship 2020 this year, since there was this pandemic. So we had conducted it virtually. Many students across the country participated in that. So we are very active in all these various activities. Okay, so you can follow us. If you have any questions or queries regarding any particular software, you can visit our website, fossi.in, and you can also write to us. info@fossi.in is our email ID. So if you have any issues or queries, or whatever you want to know, please do get in touch with us, and we'll be happy to help you out. Yeah. So hope it was an informative session for everyone. Thank you, everyone. Thank you.
Thank you, Yash. Usha ma'am, can we close the session now?
Yes, sir. Actually, we are very thankful that we could actually introduce whatever initiatives we are doing to all the faculty members and students who are present here today. And thank you, MNIT and NIT Patna for giving us the opportunity to showcase our work. Thank you.
Sure.
Yeah.
Yeah. So, thank you all. I will just like to thanks to Professor Kannan for sharing us the work what IIT Bombay is doing. And we are really thankful for Professor Kannan to be here present during the whole time. He listened everything and he just try to sort out the problems which the project members are facing. So we are really thankful, Professor Kannan. And like I would thank to all the members that who are present: Saurabh, Rajesh, Nagesh, Ankit, Mita, Ashley, Priyam, Kush, Kushal Singh, Danish, and Professor Pennan for giving us a demonstration for all the open tool softwares which can be useful for different streams. And I hope that the participants who have attended this session are really enriched with the knowledge what available in the open platform, so that they can use it at their for their uh, teaching as well as in the research. Sir, over to Professor Kannan. Sir, do you want to say something, sir?
No, I want to thank you for giving this platform. We are very happy that your students showed a lot of interest. There were a lot of questions about giving feedback and so on. I don't want to take too much time. It is already very late. But as all our presenters already mentioned, we'll be very happy to work with anybody who's interested. As I always say, that open source software is like a religion. We believe in it and we like to perpetuate it, propagate it. Ready to help everybody. What is more important is it's possible for at least some people to even contribute and make their work seen by the rest of the world, and they can become our partners and so on. We have already explained in great detail, and so I want to thank you again.
Thank you, sir. Thank you so much.
Yeah, thank you very much, sir, from our side also. Thanks a lot.
Vinit, sir?
Thank you, sir.
Please.
Yeah, I'm just thanking him for his whole effort, and we'll really fondly remember you, sir. And if you agree, please keep a patronage to us when we organize some few programs next time. We'll definitely expect support from you, sir. Thank you very much.
Okay, thank you. Bye.
Thank you so much, sir.
Participants, please don't go away. We have a small announcement for you. Participants. Yes,
sir,
yes,
are you
sir.
going to announce? Are you going to announce?
Yes, sir. Please, sir. You, please, sir.
No, sir. Please go ahead. Please go ahead. Prashant, sir, welcome. So, participant, this is the thank you for attending the third day session. There is an announcement for the fourth day. Tomorrow again we are going to meet at 2 o'clock, and the very first lecture at 2 to 3 o'clock will be given by Professor Aprajita Oza on learning management system. And after that, as we have seen that there is a lot of queries, or I can say some issues related to Canvas. So the Professor Vineet Saula and Dr. Amit and I myself, as well as that time the Professor Aprajita Oza will also be there. So we will try to sort out the we will take the issues and we will see that how we can sort out that issues. That the half an hour we will do that activity in the online way. And after that we will launch a one quiz. That is the quiz number 1 in this program. That will start from 3:30, and the all other informations related to that quiz will be communicated to you through you, and the quiz will be conducted only through the Canvas. Only through the Canvas. No other thing is required in that. only you have to attempt the quiz in the canvas. And after that, there is a one more lecture from 4:30 to 6:30. So this is the announcement. So over to Amit.
Yes, sir. So as sir has pointed out that means tomorrow we have a quiz on canvas. Now participants, if you want to access a material, then video lectures are available on YouTube channel which you are using for viewing the content, online streaming. So where you are seeing the online streaming, at the same link you can find out your materials, whatever the lecture is being covered till this point. So we expect that whatever is being covered for 3 days, that is there in your quiz. Okay. So tomorrow we have a lecture from 2 to 3 from LMS, and then at 4:30 to 6:30 we have a lecture which is from outside India, from Brazil, that Dr. David, who is a head of a QS ranking. So probably many faculty are there. So maybe they are aware about the QS ranking. So the QS ranking is a ranking that is basically assigned to define the quality of the different university. So that head of that QS ranking would enlighten us. So I request all of you to join us, and if your college higher authority would like to also join, then we would be happy to have them. Okay. Yes, Bharat sir, I think that's all from my end.
Okay. So much, and the today's session. So have a great evening and great learning. Thank you so much.
Okay, thank you, sir. Thank you.
Prashant sir, you want to say something?
Yes,
sir,
Prashant
your voice is not coming.
Sir, I think your voice is not coming. So still your voice. I am not sure. Maybe I can.
No, but sir is it's showing unmute.
I think sir is on mute on my end, sir. I think it is showing mute only. Prashant sir, probably.
Sir, your voice is not coming, I think. Sir, we are not able to listen your voice.
Okay, sir. Okay. I think
thank you.
Sir is saying bye only. Okay. Thank you, sir.
So, thank you, Saula sir. Thank you, Amit. Thank you, all the proctor coordinators and the academic level coordinators. We will see. We will assemble tomorrow again at 2 o'clock.